Now children, in this video we will see a simple question based on the formula for entropy, right? It's a very simple question, just one question we are doing. Children, there are many formulas in our text, in our book, but all will be very much used or are equally important. Normally it is not so. So I just have taken up one simple example for this formula. Let us see. The question is 1 mole of alpha tin, it's a form of tin, an allotrope of tin, at 1 atm and 13 degrees Celsius changes to 1 mole of beta tin at 1 atm and 13 degrees C. So 1 atm, atm, both the conditions, 13 temperature the same. 1 mole of alpha tin got converted to 1 mole of beta tin under same conditions of temperature and pressure. If enthalpy of transition is 2090 joules per mole, it's given to you here. Calculate entropy of transition. Children, when they say entropy means obviously we are calculating entropy change. We never calculate only H enthalpy, we calculate enthalpy change. So here they are saying calculate the entropy, but actually it is entropy change we are calculating. It's obvious. Now temperature is given to us as 13. We have to naturally take it to Celsius. So Kelvin. So of course 13 plus 273, 286 comes out to be. Delta H transition is given to us, this value joules per mole we wrote. Now they are asking calculate entropy change. So I know delta S transition or any what all transformation was there is equal to delta H enthalpy upon T. I was writing Q reversible upon T. Children, what is Q? I told you without any saying. In most of the reactions, in 95%, 98% reactions, there's no mention, and the same Q is measured, the heat is measured, evolved or absorbed is measured at constant pressure. So that Q which was there, QP, is now delta H. So I was writing Q in the normal conditions, Q reversible upon T, but actually what is that Q? Q is without mention anywhere. If nothing is mentioned, it simply gradually takes up the shape of enthalpy. Nothing but Q, same Q measured at constant pressure. When nothing is mentioned, so in these formulas where it was Q reversible upon T, it has taken the shape delta H upon children. I used to write delta S is equal to, it was Q reversible upon T. So what is this Q reversible upon T? Q reversible is nothing but the Q means heat given or out, absorbed, whatever is there at constant pressure. When there is no mention, it is obviously at constant pressure, which was nothing but delta H. So formula was Q reversible. So you will say, where is the Q given? Q was heat, but actually it is nothing but the enthalpy. What enthalpy? Same Q, same heat evolved or absorbed, whatever is there, is measured at constant pressure. That's why I wrote initially in different video that it was a QP in short taken as H and it was a QV in short taken as E or say U. Have shown this if you remember. So children, how this form has changed. They said enthalpy. You will say I have studied the formula Q reversible upon T and here you are writing delta H. It is one and the same thing here for this formula. Reason being, our Q is measured at constant pressure. So naturally it is H, and we know that we never are able to mention just H or measure just H. So it is delta H. So delta S is equal to delta H upon T, which was from here only. And the value was given to us, which is equal to this after calculation. So the same formula Q reversible upon T has taken this shape automatically because this Q is nothing but Q measured at constant pressure. When nothing is given, it is taken for granted the energy content, the heat content is measured at constant pressure, which is H. You say this is an exothermic reaction gives out 100 joules. So 100 is its enthalpy. You say heat, it gives out 100 joules of heat. But heat is measured at constant pressure, the same Q, which you're saying it gives out 100 joules of heat, same Q is actually, without any mention, is measured at constant pressure. So same Q is now QP, and QP is what called enthalpy. Finally, H. So that's why the formula which we have studied is delta S is equal to Q reversible upon T, but has taken this shape because Q is nothing without mention, measured at constant pressure, which is H, and so it is formula is delta H upon T. H was nothing but heat content measured at constant pressure, and here it was Q reversible upon T. So this Q was actually QP. QP is nothing but H, so the formula has changed to delta H upon T, and that's how you got direct formula based question, simple question you need to know. Actually children, what happens, numericals involving entropy, there are some more formulas to be used and they are mainly asked there. Or it can be the formula which I gave you, the delta S is equal to 2.303 nr log V2 upon V1 I gave you in last video. So you have to remember children, the chapter is full of formulas. It's more of physics, and that too I tell you, the thermodynamics is mainly, I told you in the beginning also, mainly the part of mechanical engineering. So here you cannot relate much what is happening in your daily life, mechanical engineering, machines and all. So for us it is the way possible I'm teaching you, and I've given you formula, simple formula. Yes, you need to know and try to solve this question yourself too. You can see many more examples in the book. So this is for this video. We stop.